isomerism in complex when the cation and anion both are complex ion. There may be exchange of ligand between these two complex ion, resulting coordination isomer. In the pair of this isomer, centimeter cation and two coordinations pair may be the same or different. So, what is coordination isomerism? Cation both anion both are complex ion. So, ligand exchange between the two complex ion. So, in this way, coordination isomer is formed. So, some example of coordination isomer are given below. CuNH36, CrCN6, and CnH36, CuCN6, CuNH34, PtCl4, and PtNH34, CuCl4, CuEN3, CrCN6, and CrEN3, CuCN66. PtNH34 PtCl6 and PtNH34 Cl2 PtCl4, CnH36 CrCN6 and CnH34 Cn2, CnH32 and Cn4. Coordination position isomerism. In bridging complex and exchange of non-bridging ligands between the two metal cation give rise to coordination position isomerism. So what is coordination position isomerism? So coordination isomerism, what is it? So the two metal cations are linked by a non-bridging ligand. So this is kind of complex known as bridging complex. So in bridging complex, the two metal cations, between the two metal cations there is a non-bridging ligands. So this kind of isomerism is called coordination position isomerism. Here, for example, NH3 4 CO3 NH2 2 CO NH3 2 Cl2 2 plus and Cl NH3 N3 CO NH2O 2 NH3 Cl2 plus NH3 N4 COOH OH CO NH3 2 Cl2 plus and Cl NH3 N3 COOH OH CO NH3 3 Cl2 plus. Ligand isomerism. If ligand exists, itself exists in two or more isomeric forms, then complex contents of ligand also exists in isomeric forms. Example of isomeric ligand. So ligand isomerism क्या है? Ligand जो है, ligand exists in two or more isomeric form, and complex contents of ligand also exists in isomeric form. So in this compound, ligands is itself form a two or more isomeric form. So such complex will be ligand isomeric. So here this is a ligand CH3 CH CH2, both the CH and CH2 is bonded by NH2 1,2 diamino propylene diamine PN. So CH2 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 CH2, both the CH bonded by NH2 to 1,3 diamino propene trimethylene ethylene diamine. So both the formula is same, composition is same, but arrangement of atom is different. So this ligand can form more than two isomers. So this kind of ligand, if it is attached with a centimeter cation, then that kind of complex will be ligand isomerism. Orthometa p toluidine, orthotoluidine NH2CH3 NH2CH3 M toluidine NH2CH3 p toluidine. The two isomers containing ligand PN and TN, CuAPN2 Cl2 plus and COTN Cl2 respectively. Polymerization isomerism. 7th, polymers are not real polymers. This isomers have same empirical formula and same molecular formula. All these isomers have the same ratio of metal atoms and ligands in them. Polymerization can be illustrated by coordination polymers of Pt2 plus and CO3 plus. So this polymerization isomerism is not a real polymer. So what is this isomer actually? This isomer has same formula, but instead of molecular formula, they have same empirical formula. So their metal atom ratio is same, ligand ratio is same. So there's an example about platinum 2 plus and cobalt 3 plus. Complex compound number of Pt NH3 2Cl2 Pt 2 plus 1 NH3 2Cl minus 2 Pt NH3 4 PtCl 4 2 4 4. Then Pt NH3 4 Pt NH3 Cl 2 Pt 2 plus is 3 NH3 is 6 and Cl is 6, so 1 is to 2 is to 2. Then PtNH3 Cl2 PtCl4. So here also 3 platinums are there, 6 ammonia and 6 chlorine are there, so it is 1 is to 2. Coordination polymer of CO3 plus complex compound. Here CONH3 3 NO3. So number of copper 3 plus will be 1, NH3 will be 3, NO2 minus will be 3. Then CONH3 6, CO2 6. So number of cobalt is cobalt 3 plus is 2. Number of ammonia is 6. Number of nitrate is 6. So it is 1 is to 3 is to 3. Then CONH3 4 NO2 CONH3 to NO2 4. So CO3 plus will be 2. NH3 will be 6 and NO2 will be 6. So once again ratio will be 1 is to 3 is to 3. So here empirical formula means ratio of center metal ions ligands, either it is in coordination sphere ionization sphere, will be same. Only empirical formula, not molecular formula. So this kind of isomerism is called polymerization isomerism. Next is stereoisomerism, the isomer in which the same number of ligands are coordinated to metal atoms or cation but with different spatial arrangement. So here what is stereoisomerism? Stereoisomerism where number of ligand is uh, same number of metal ions are there, okay, but the spatial arrangement is very different, so that is called stereoisomerism. In other words, stereoisomers are the isomer that differ only spatial arrangement of ligand coordinated to metal cations or atom. So that means stereoisomer is a kind of isomer in which the ligand is in different spatial arrangement which is coordinated bonded with the center metals atom. So the difference is only about the spatial arrangement of ligand. So stereoisomers is classified into two types: geometrical isomerisms and optical isomerisms. Geometrical isomerisms: stereoisomers in which relative position or orientation of ligands, or more specifically donor atoms and around the metal cation, is different, are called geometrical isomers, and this phenomenon is called geometrical isomerism. So what is geometrical isomerism? This is a type of stereoisomers where ligands positions, okay, donor atoms specifically around the metal cation is different, around the metal cation is very different. So that kind of isomerism is called geometrical isomerism. Here in this geometrical isomerism is a kind of stereoisomer where a number of ligand or specifically donor atoms is joined to the atoms around very differently. Geometrical isomerism cannot be interconverted without breaking Ml bond. So could it be interconverted? It can, but Ml bond should be break down. Metal and ligand bond should be break down. Geometrical isomer exists only in pairs. In one isomer, the two particular ligands are adjacent to each other, and in the other, the two are in opposite side in the structural formula. Thus, the isomers in which two particular ligands, either identical or non-identical, occupy the adjacent position of others is called cis isomer. So, what is cis isomer? It's a kind of isomer where two same ligand, whether it is identical or not identical, is occupy two adjacent positions of each other. That is called cis isomer. Okay. So in this cis isomer, two ligand, either it is identical or not identical, they occupy the adjacent position of each other. This is called cis isomer. Then The isomer in which two particular ligands occupy opposite positions to each other is called trans isomer. So what is trans isomer? Two particular ligand, whether it is identical or not identical, but they are opposite to each other, that is called trans isomers. The Latin word cis means next to and trans means across. So in Latin, the meaning of cis is cross to, and trans means across or opposites. Sorry, in Latin, the meaning of cis is next to or close to, and trans means across or opposite. Cis and trans isomer are different compounds with different property like melting point, dipole, solubility, color, and chemical property. So, what is the difference between the cis and trans isomer? See, in cis isomer, uh, whether ligand is identical or non-identical, but they will be adjacent to each other. Means they will be next to each other. But in the trans isomer, a particular identical or non-identical ligands will be opposite to each others. So both cis and trans show difference in solubility, melting point, boiling point, color, and different chemical properties. For example, cis platinum NH3Cl2 is a polar molecule. This is a cis platinum which is very famous for cancer agent drug. So this is a polar molecule and is more soluble in water than trans platinum NH3 2Cl2 molecule, which have zero dipole moment. So between the cis and trans, we can understand that PT NH3 2Cl2 is more polar, so it is soluble in water. Okay, but trans PT NH3 2Cl2 is not polar, so it is insoluble in water, and its dipole moment is zero. So we can understand that it is not trans isomer of cisplatin is not polar at all because zero dipole moment. Also, cis platinum NH3 2Cl2 is called cisplatin, is an effective anti-cancer drugs, whereas trans isomer is physiologically inactive. So this PTNS32Cl2, which I already told you, is known as cisplatin. So it is very famous for anti-cancer agent drugs. The trans isomer is a very inactive physiologically. Geometrical isomer is most common in complex having coordination number of 4 and 6. The complex which exhibit coordination number 2 and 3 do not exhibit geometrical isomerism. So this geometrical isomerism is very common in the coordination number 4 and 6, but it is not exist in coordination number 2, 3. Okay, so we can only observe this kind of geometrical isomerism if the complex number is 4 and 6. That's it. Another example is about geometrical isomerism is a difference between the lemon and the orange. Lemon and orange both are citric fruits and their taste is very different from each other, but the chemical composition is same. But however, due to the difference in their isomer, because one of them is cis, another is trans, because of this cis and trans isomers, both lemon and orange taste very different from each other. One is sweet and other is sour, but both are under the family of citric fruits. So because of this cis and trans isomers, both the molecules taste very different. Tetrahedral complex known as exhibit geometric isomerism complex which exhibit coordination number. Tetrahedral complex do not exhibit geometric isomerism whether all the ligands are same or different, because all the ligands in their geometry are at the adjacent position related to each other. Each ligand is present 109 degree to 28 minutes from each other triangle. So tetrahedral complex doesn't show geometric isomerisms whether ligand is same or different, but still the ligand will be adjacent position to each other. The bond angle will be 109 degree 28 minute. Square planar complex such as Ma4 n plus minus Ma3b n plus minus Ma8 n plus minus Maab n plus minus MaaA2 n plus minus type square planar complexes do not exhibit geometrical isomerism because all possible spatial arrangement of ligand around the metal cation is the same. So these square planar do not show geometrical isomerism. The reason is that the ligand spatial arrangements of all possible, the same cation is the same. All the possible spatial arrangement of ligand around the metal cation is the same. Why the square planar complex doesn't show geometrical isomerism? Because when the metal is bonded with the ligand spatial arrangements are same. All the ligand spatial arrangements are same. So this doesn't show any difference with each other, and therefore square planar will never show the geometrical isomerism. Ma2b2 n plus minus type complex of type of complex are PTNH3 2Cl2, PTPy2 Cl2, etc., which exhibit geometrical isomerism. Cis trans isomer of PTNH3 Cl2, for example, are shown. Cis isomer and the trans isomer. Right now we had learned about the difference between the cis plantain and the transplanting. Cis and trans isomer of PTNS3 to Cl2 square planar complex. So cisplatin and the transplatins show square planar complex. Cisplatin and transplatins, they show geometrical isomerism and their geometry is square planar geometry. So next is Ma2BC n plus minus type of complex. Example of this type of complex are PTNH3 2PyCl plus PTPy2NH3Cl plus PTNH3 2NO2Cl, etc., which exhibit geometrical isomerisms. Cis and trans isomers PTPy2NH3Cl plus, for example, are shown. So Ma2BC plus minus show geometrical isomerism because they have cis and trans isomers of each other. Here we can see that PTNH3 to PyCl, here two ligands are same but remaining two are different from each other. Because of that they can form the cis and trans isomer. Here pyridine are adjacent to each other in cis isomer, and trans isomer pyridine is opposite to each other. So this can show geometrical isomerism. MABCD n plus minus type complex. So square planar complex of this type exists in three isomeric form. So this complex show three isomeric form: NH3PyClBr, NH6ClBrPy, then NH3ClPyBr. So they show three isomeric form. Three geometrical isomer of PTPyNH3ClBr. The three isomer of PTPyNH3ClBr, for example, can be obtained by fixing one ligand, say NH3, at one corner and placing the other three ligands one by one trans ammonia. So how we could get the three isomer from this kind of complex of ABCD n plus minus? If we fix the ammonia in one place and change the position of remaining ligands, such as C. Here in first one, ammonia is fixed. Py, Cl and Br's position is changed. Then second isomer, ammonia is at the same position. It is fixed. So once again Cl, Py, bromine position will be changed. Next is ammonia still is fixed on the third isomer. So same position is occupied by ammonia. So Py, BrCl, once again the position will be changed. So here we can observe that this kind of complex of square planar geometry have three isomeric form by fixing one ligand and keep changing the position of remaining 3 ligands. Other example of such type of square planar complex which can exist in 3 isomeric form: P2C2H4 ammonia ClBr, PTPy ammonia NH2OH NO2 plus, MeB2 N plus type complex. Here M is the central metal cation and AB is an unsymmetrical bidental ligand in which A, B are two different donor atoms. Example of such type of complex are PT glide 2 copper glide 2, this is, and transisomer of PT glide 2 are shown. So in this type of complex, uh, this type of complex, okay, is a bidentate ligand. So this kind of complex is unsymmetrical bidentate ligands. So these bidentate ligands have two different donor atoms. Example is PT glide 2 copper glide 2. So these both are in cis and trans form. So PT NH2CH2COO, P2 NH2CH2CO. So NH2O, they are opposite to, they are adjacent to each other, so they are in cis form. Here in this also P2NO glide. So this N and O is actually donor atom of glycine and it is shown in the curve form. Why? Because glycine is a very very big molecule. So if any ligand show big molecule, we can show the donor atom, and around that two donor atom we can show the curve and we can write the prefix name of a ligand outside the curve. Then here in the transform PT NH2CH2OCO ONH2CH2CO, here oxygen are opposite to each other, NH2 opposite to each other, so they are showing trans isomer. And this is unsymmetrical bidentate ligand where two donor atoms bonded to the center metal. Next is Bridget bionuclear square planar complex of Me2 M2A2B4 type. Bridget binuclear square planar complex of Me2A2B2 type can exist in 3 isomeric forms: cis form, trans, and unsymmetric. The 3 isomers form PTE, PET3, Cl2, for example, are shown in figure 2.19. But only cis and trans isomer of most of the complex of this type have been formed. So what is this kind of complex, what does it show, and what we can learn, and how these are forming geometrical isomerisms. So this is Bridget binuclear square planar complex. Okay, so what does it showing? It's showing the 3 isomers. It is showing that one molecule can show 3 isomers, either cis, trans, and unsymmetric. So these three isomeric form of the molecules show cis, trans, and unsymmetric to each other. Now here cis, Cl, 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 PT, Cl. So the Cl is adjacent to each other. But in the trans form, if we try to observe that in the Bridget ligand, two ligand will be the same, Cl, Cl. But to the adjacent of platinum Et3P and another platinum Et3 PET3, they are opposite to each other, so it is transformed. Though the bridging ligand is the same, but bridging ligand will never be considered, considered. Okay, only the adjacent ligand with the center metal atom will be considered. Here Cl, Cl, PT, Cl, Cl, PET3, PET3, which is unsymmetric. Geometrical isomers of PT2 PET3Cl4 bidentate bridge ligand. Square planar complex with symmetric bidentate ligand carrying one or more substituents can form geometric isomers. So this square planar complex with symmetric bidentate ligand show geometric isomers. PTPN2 plus exists in cis and trans isomeric form, in which methyl group are cis trans respective with each other to the median plane of the ring atoms. So square planars complex by symmetrical bidentate ligands show geometric isomers. Cis and trans are median plane of the ring atom in the cis and trans form. So cis form NH2CH2 CCH3 NH2 NHCH2 CCH3 NH2. This ammonia is this molecule is adjacent to each other, where then here NH2 NH2, though donor atom is same, but adjacent to the carbon atom the methyl group is in different position. Here in trans isomers the methyl group is opposite to each other respective to the carbon atom which is attached to the ammonia. So this transform methyl group's position is different. So so we must give more attention to the methyl group which is attached to the secondary carbon atom which is bonded to the donor atom. That methyl group we should keep attention, and it will show that this is a transforms. Cis and transform isomers. And another example of complex is that having bidentate ligand with two methyl substituents as shown. Now here once again NH2CCH3H, NH2CCH3H. So NH2CCH3, NH2CCH2. So we shouldn't consider the donor atom. We should always consider the position of the methyl group which is bonded to the secondary carbon atoms. The secondary carbon atom is bonded to the donor atom. So we must observe the position of the methyl groups, two methyl substituents. So this is cis form. Then what is the difference of trans form? Here the methyl group's position is changed now, which is bonded to the secondary carbon which is bonded to ammonia. Then here on the other hand the methyl group position is same as it was, which is bonded to secondary carbon atom and bonded to the ammonia. So here number of atom is same type of atoms are there, same type of element are there, isn't it? And same donor atoms are there, and the donor atoms position also same. What we must observe? We must observe the position of the methyl groups which is attached to the carbon atoms, secondary carbon atom, the secondary carbon atom which is attached to the donor atom. So the methyl group we should focus on it to determine the isomers. Geometrical isomerisms in octahedral complex. In an octahedral complex, a methyl cation will present in centers of octahedrons, and the 6 ligand occupy the 6 corners number from 1 to 6. So this is a octahedron complex, okay, where all the 6 ligand will occupy the positions at the corner when bonded with the metals. Mn plus L, 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 L. It is in square pyramidal structure, right? Square. So arrangement of 6 ligand in octahedral complex around the metal ion. So it is in octahedral complex, sorry. In cis isomer of two similar ligand or sometimes two different ligand of interest occupy the corner of octahedral adjacent to one another. The cis isomer and the same ligand occupy either of position 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 2, 3, 3, 4, 5, 2, 6, 2, 6, 3, 6, 4, 6, 5. So what is this cis isomers? Why it is so peculiar? So this cis isomers have two similar ligands, and two different ligands occupy a corner of the octahedral adjacent to one another. So in the cis form, all the same ligands occupy the position which is 1 2 1 3 1 4 1 5 2 3 3 4 4 5 5 2 6 2 6 3 6 4 6 5. If the same ligands is occupied in this position, they are considered a cis isomer, which is quite too long. Okay, so in trans isomer, this ligand are lying opposite to one another on the straight line which passes through the center of octahedron. In trans isomer, the two ligands under consideration will occupy either of the position. So if the two ligands are same to each other and they are trans isomer, how we are going to identify? How we are going to determine that these two same ligands of octahedral complex are trans isomer to each other? So it is not too long, it is very short. So the ligand should be at the position of 1 and 6, then 2 and 4, and 3 and 5. See, it is too simple, right? So the two ligands, if it is at the position of 1 and 6, 2 and 4, and 5 and 3, if they are at this position where they are opposite to each other in certain position, then they are considered trans isomer. So we should remember that if the two ligands are same to each other in the octahedral complex, so how we are going to identify that it is a trans isomer? So we must remember that this ligand will be at a certain position which makes themselves as opposite to each other, which is 1 6 2 4 and 5 3. Okay, so at this position it will be considered the trans isomers. Okay, remaining will be for the cis isomer, which is 1 2 1 3 1 4 1 5 2 3 3 4 4 5 5 2 6 2 6 3 6 4 and 6 5. Next is, since all the corners of a regular octahedra are equivalent, there are no geometrical isomers of the complex of the type Ma6 n plus minus Ma5b n plus minus Ma3, where AA is symmetrical bidental ligand. So in this regular octahedron, metal and ligand's bond length will be the same, equal. So geometrical isomer of this complex Ma6 n plus minus Ma5b n plus minus Ma3. So this AA is symmetric bidental ligands will show octahedral geometrical isomerism. Ma4b2 type of complex. The complex of this type exists in cis and trans isomeric form. Example of this type of complex are CuNH4Cl2 plus, CuNH3,4NO2 plus, etc. This is trans isomer of CuNH4Cl2. So this NH3 are adjacent to each other. CRC is adjacent to each other. Ammonia is adjacent to each other. So this is form. Here CRC adjacent to each other. Ammonia are trans to each other. In cis isomer, the two chloride ligand occupy the adjacent position 1 and 2, and in trans isomer, the two Cl ligand occupy position opposite to each other, which is 1 6. The cis isomer has blue-violet color, where trans isomer has green color. So what is the difference? Here number of this ligand is same. The same type of ligand atoms are there, What is the difference? See here, in cis form, ammonia, okay, they are adjacent to each other, opposite to each other, but chlorine are cis to each other, are adjacent to each other. Ammonia is also adjacent to each other, but the trans isomer Cl are opposite to each other. Ammonia, Cl ammonia is trans to each other, adjacent to each other. So this cis form complex will show blue violet and the trans form will show green color. CuNS3Cl2 Ma4Bc N plus minus type complex. Complex this type also exists in cis and trans isomer. Example of this type of complex: CuNS3,4H2Cl2 plus CuNS3,4Py Cl2 plus the etc. The cis and trans isomer of CuNS3,4H2Cl2 plus. So cis isomer. Here this is cis isomer and this one is the trans isomer. ClOH2 are different. Ammonia is adjacent to each other. Ammonia is adjacent to each other. Ammonia OH2. So these are trans isomers. This is isomer H2O Cl minus. Ligands are adjacent position, where trans isomer this ligand are on opposite position. Next is facial and meridian isomer. So what is facial and meridian isomer? In facial isomer, three identical donor atoms lie on the corner of a triangular face, and in meridian isomer, the three identical donor atoms lie at the corner of a plane bisecting the complex. There are four types of complex which exist: FAC, facial, and MER, meridian isomers. So what is facial isomer? Three donor atom is there of a ligand. They are same to each other, and they occupy at the corner of a triangular face. Okay, at the corner of a triangular face, they will occupy their position. But when in meridian, here same two donor atom are there, but they also occupy corner, but they occupy the corner of a plane bisecting the complex. If a plane is bisecting the complex, in its corner, the three same ligand will be there. So in this, the plane bisecting plane corners, three ligand will be there. That will be three same ligand will be there. That is called meridian isomer. And in facial isomer, three same ligand will occupy the corner of triangular face. That is facial isomer. Facial isomers prefix is FAC, and meridian isomers prefix is MER. Me3B3 N plus minus type complex. Some example of this type of complex are CnS3Cl3, CnS33CO NO23, CnS3Cl3, etc. Facial or cis. Facial is a form of a cis isomer. Meridian is a form of the trans isomer. In the facial, we know that the three same ligand will occupy the corner of triangular face, and in meridian, the three same ligand will occupy the corner of bisecting plane. So the FAC facial isomer is cis form, and meridian is trans isomers. In FAC, The CL bond angle are 90 degree, which is while in the meridional CL bond angle are 90 degree and one is 180 degree. Also we say the meridian isomers 3Cl minus ligand lie in one plane and the remaining 3 ammonia ligand lie in perpendicular plane. This complex is called meridional because each set of ligands can be regarded as lying on meridian of a sphere, larger circle that can drawn on the surface of the sphere. So in this facial isomer where the three same ligands occupy the corner of triangular face, here CL will form 90 degree. But in a meridional isomer, the CL will form 90 degree as well as the CL another CL will form 180 degree. So this same kind of angle is showing different kind of angle degree, and the three same ligands occupying the corner of a bisecting plane and they are perpendicular, and the three same ligand which is at the corner of the bisected ligand, they lie perpendicular to each other, so they are called meridional. Why it is meridional? Because these ligand are perpendicular to each other, they are lying at the meridian of sphere. It is the largest circle that can drawn on the surface of a sphere. Then MABE. Hello. हाँ.